Hey everybody, it's Miss Maneely, and I am here to go through your final exam review packet with you. In Honors Algebra 2, or in Algebra 2 in general, there will be two sections to the final exam. There will be a calculator section as well as a non-calculator section. You will be given formulas ahead of time so you know what you'll be allowed to use on the exam. For example, like the unit circle, you'll have access to that. And then we'll also have other formulas that you'll need. And so you know what you can use ahead of time. All right, so let's get started on the calculator section. You'll notice that it starts off with trig. There is a lot of trigonometry on your final exam, and which is a good thing because you guys actually did pretty well with that unit. So there's a lot of things you do have to remember, though, about that unit. So you might need to go back through your notes to review in addition to these problems. So number one, it says, suppose that a sector has an arc length of 3 pi over 2 centimeters and a radius of 10 centimeters. What is the radian measure of the central angle of the intercepted arc? So let's first make sure we understand the question. We're given the arc length, which is 3 pi over 2 centimeters, and we're also given the length of the radius. So when we're talking about the central angle and the intercepted arc, think about a circle. Here's our central angle is right here, so that's theta, and then this is our arc length. And we call that S. I don't know where the S comes from, but if you remember, the arc length is equivalent to theta times the radius, and so obviously this is our radius. And one important thing you do have to remember is that the theta has to be in radians. So if you're given the arc length, if you're given theta, if you're given the central angle in degrees, you will have to change it to radians. And I wrote radius and I meant to write radians, sorry. You will have to change it to radians first. And so remember, to go from degrees to radians, so if I'm given degrees and I want to go to radians, since in degrees, I don't have a pi. Remember, we use the degree symbol. So if I don't have the pi, I'm going to want to multiply by the fraction that has the pi on top in order to get it into radians. So I would multiply my degrees times pi over 180. If I'm given radians and I want to change to degrees, that means I have a pi and I want to get rid of it. And so I'm going to multiply my radians by 180 over pi, and that way my pi's will cancel. So if you're given theta and you need to use this formula and you're given the degrees, you need to put it back into radians. Okay, but let's take a look at what we have. We know the arc length is 3 pi over 2. So since it's the arc length, I know that's my S value. So 3 pi over 2 is equal to theta times r. Well, I'm given the radius of 10 centimeters. So I don't know theta. Theta times 10. And so to solve for theta, I'm just going to divide both sides by 10. Now, since you're dealing with fractions, you might want to just think about your rules for fractions. Dividing by 10 is actually the same thing as multiplying by 1/10. And that way, those 10s are going to cancel. And then if I simplify the left-hand side, and I don't have a ton of room, I'm going to end up with 3 pi over 20. And that's my theta value. And it's in radians. Notice that there's a pi in my answer, and so that tells me that it's already in radians. So theta is equal to 3 pi over 20. And if you want to write radians, you can, but it's implied with that pi in your answer. Okay, and number 2, you're talking about coterminal angles. And I just realized that I spelled coterminal wrong in the second sentence. I think I was doing spell check and it changed it for me. Okay, so what is a coterminal angle? A coterminal angle is basically when two angles share the same terminal side. So two angles sharing the same terminal side. And so, for example, I don't have a ton of space, but let's say here's my angle in standard position. So remember, our x-axis is standard position. So if this is the terminal side, so this is what we would call the initial side, and this is what I would call the terminal side, I could say that here's one angle. I'll call that theta 1. And my other angle would be maybe this angle here, which I would call theta 2. And because the angles share the same terminal side, we can call them coterminal angles. So in letter B, it says you're to give two coterminal angles of an angle with a degree measure of 276. There's two things you can do here. Basically, you're just going to wind around the circle one way or the other. It would be one way to do it. So you could add 360 or subtract 360, and that'll give you coterminal angles. So for example, if we add 360, so 276 plus 360, and these are actually the same angles, is going to give you an angle measure of 636. If I subtract 360, it's going to give me a negative 84 degree angle. Okay. If you think about what a 276 degree angle is, so again, I'm sort of running out of space here, but you know, if this is my standard position, think about your actually, let me just go ahead and draw my x and y axis. So if I start my angle here at 0 degrees, my terminal side for 276, I know that 3/4 of the way around the circle is 270, so 276 degrees would be here. So this is a 276 degree angle. So another way to do it would be to figure out what this angle is here, which is basically going to be 360 minus 276. And so that would be a positive or a negative 84 degree. So that's where this negative 84 degree angle comes from. But you could also do a positive, I'm sorry, that's where the negative 84 degree angle comes from. So that's going to be your coterminal angle. And then obviously you can do any variation of that. Adding 360, subtracting 360, and they're all going to be coterminal. All right, and number 3, there's a problem like this on the exam, but you're not given a diagram. So I put the diagram on here because I thought it would be easier for you guys to visualize what the question is asking. So basically, you're told you have two central angles, theta 1 and theta 2, that are constructed in a circle of a diameter with 40 inches as shown below. So I constructed it so that the two angles are right next to each other, but you don't have to have them next to each other. I just think it makes the problem a lot easier to solve if you put the angles right next to each other. It says the angles do not overlap, which is important, and the arc length associated with theta 1 is 8 inches, and the arc length associated with theta 2, with the second intercepted arc, is 7 inches. Okay, and so it might help on a test to actually draw this picture. And so I put the image here just to kind of help you set it up. And it is a lot easier if you put the angles right next to each other. Because what it's asking is to determine the sum of the two angles, theta 1 plus theta 2. This is basically a variation of problem number 1. You're given something about the radius. It doesn't specifically give you the radius of the circle, but you certainly can find the radius of the circle if you know that the diameter is 40 inches. And you also know the arc length of the angles, and what you're asked to do is find the sum of the interior angles, which, if you think of it, basically, if I look at my circle the way I've drawn it, I know that the radius in the circle then is just 20 inches. And if I think of it instead of two separate angles, if I put them next to each other, I can just think of this as one big sector. And so instead of looking at it as two individual arcs, I would look at it as one big arc, where my radius is 20 inches. My arc length, then, is going to be the sum of the two smaller ones, which is going to be 7 plus 8 inches, or simply 15 inches. And if I'm asked to find the sum of these two angles anyway, so, let me just call that theta. I don't have to call it theta 1 plus theta 2. Let's just call it theta. I'm trying to figure out my interior angle, which is exactly what we did in number 1. So in this case, I'm going to take my arc length, which we know is 15, and I'm setting that equal to theta times r, which in this case is 20. And if I divide both sides by 20, this time it's a little bit easier, 15 divided by 20 is 3/4 or 0.75, and that is theta. And in fact, in this case, it's going to be theta 1 plus theta 2, because that's how I defined theta. So when you see this problem, draw a picture of it and put the angles next to each other, and instead of thinking them as two separate angles, just put them together and think of them as one big one. Okay. 4 and 5 get back into doing graphing of trig functions. So in number 4, it says to consider the function g of x, which is equal to -1/2 times the cosine of x plus 5 pi over 6 minus 3. It says describe in words the transformations of the function g of x in terms of the parent function f of x equals the cosine of x. So we have a couple things going on here. So I've got this -1/2 out in front. I've got this x plus 5/6 on the inside of those parentheses, and I've got this minus 3 on the outside. So let's deal with each of these terms individually. So my a term, if I'm thinking of this in terms of a, h, and k, I'm looking at my a term. So if I call this a, and I call this h, and I call this k, I'd say that a is equal to -1/2. And so I need to talk about what this is doing to the graph. Remember that our a value does two things. It incorporates a reflection and also a dilation of the graph. And when we're thinking in terms of the sine and cosine function, that dilation is also going to correspond to the amplitude of the function. So what I could say here is because of that negative, I know that represents a reflection. And it's a vertical reflection, vertically reflected. Okay, that 1/2 tells me that the graph is compressed. And it's going to be, again, compressed vertically. And so the parent function has an amplitude of 1. This function is going to have an amplitude of 1/2. Okay, and remember, amplitude is always positive. All right, so the next term we want to look at is the h term. And you got to remember that in the formula, it's x minus h. So the fact that I see an x plus 5 pi over 6 tells me that h is actually, and actually let me do this in a different color. It tells me that h would be a -5 pi over 6. And so h, remember, is our horizontal shift. And so the graph now is going to be shifted to the left 5 pi over 6 units. Another way to think about this is that the period or the cycle of my function is going to be starting at -5 pi over 6. So it's a left shift of 5 pi over 6 units. Okay, and so the left when I say left shift, it's taking care of that negative. Another way to think of it, though, is that the cycle starts at -5 pi over 6. And then our k value, now that doesn't change sign, so I'm going to leave my k. And actually, let me see if I can adjust this a little bit. Let me scoot that down. Okay, so my k value, let me do this in a red pen, my k value is equal to a -3. And so that -3 is going to be either an up or a down shift. And in this case, it's going to be a downward shift of 3 units. Oops. K also gives us the equation of our midline. Oops. And so it's going to be y equals -3 will be the equation of our midline. Okay, we're not asked to graph it, we're just asked to describe in words the transformations. All right, in number 5, you're given a graph and you're asked some questions about it. So remember, the sine and the cosine function, when they're graphed, look identical. So it just depends on where we want to start the cycle. So there's an infinite number of equations that can model any sine or cosine graph. So there are going to be some things in common. For example, they'll all have the same amplitude and they'll all have the same midline. So in order to figure out the amplitude, though, I do have to figure out the midline. Or we can use what we know about the max and the min. So actually, let's do it that way. I know that the max of this function is at +1, and the min of this function, my minimum value, is at -5, right? So the amplitude is basically the distance between the max and the min cut in half. And so if I wanted to find it from my max and min, I'm going to subtract them. So I would do, for example, so the amplitude would be -5 minus 1, and then I want to cut it in half because the -5 minus 1 will tell me the distance from max to min, but I want to cut it in half. And so that's going to be -6 over 2, which gives me an amplitude of 3. And remember, the amplitude is always going to be positive. So even though when I do this I end up with a negative number, the amplitude is going to be a positive 3. And actually, I guess I should have done max minus min. Let's do it that way. Max minus min, since it's the biggest number. So my max is 1. If I subtract my min, I'm subtracting a -5. Sorry, I should have done it that way. And that'll give me a positive 6 over 3, or 6 over 2, which is going to give me an amplitude of 3. You don't have to remember the formula. In part B, when it's asking for the equation of our midline, remember the midline is the average. So the midline is going to equal, if I find an average, I'm adding them. So 1 plus a -5 over 2. That's going to be -4 over 2, or simply -2. And so my midline would be at the equation y equals -2. Now, you don't have to use the formulas. Obviously, if you look at this graph, I can see that this line right here is my midline, and I can see very clearly that that's y equals -2. And then if I want to find my amplitude, I'm just now looking at the distance from my midline to my max and to my min. Okay, and I can just count and see that the amplitude is 3. So my amplitude is 3, the midline is -2. Those values will be the same for every function. So in letter C, it says which is not a possible equation for the graph. So notice how the coefficient in front is a 3 for each one of these. That's the way it's supposed to be. Some are negative, some are positive, so we'll have to examine each equation and where the cycle starts to see if that's accurate. And notice that my k value on all of these is -2, and that gives me the value of the midline. This is going to be a trial and error situation. So what I want to do in number 1, we're going to look at our h value first, because the h value tells us where the cycle starts. And remember, it's always opposite. So if you see x minus pi over 4, that's telling you that the cycle is starting at a positive pi over 4. And so with your graph, the increments are at pi over 2. So pi over 4 is actually going to be halfway between 0 and pi over 2. And I can see that my function starts down here. That tells me that because it's starting at the bottom instead of at the middle, that this is a cosine function. And since it's starting at the bottom, I know that it's got to be reflected. So this equation, y equals -3 times the cosine of x minus pi over 4 minus 2, works. That is a correct equation. Okay, if I take a look at number 2, I'll use the blue pen for this. If I take a look at number 2, this time my cycle is going to be starting at, even though it's a positive 7 pi over 4 inside my parentheses, I want to go to the -7 pi over 4. And since pi over 4 is just that half increment, if I just count, so this is 1 pi over 4, 2, 3, 4, 5, 6, 7. So here's my -7 pi over 4, and notice where I am. I'm at the bottom of the curve. So that tells me, since I'm at the min, that this is a negative cosine function. But if I look at the equation, notice how the 3 out front is positive. So for now, I can see this is not correct. I do want to double check the rest of them, because there may be other possible answers. So if I look at number 3, I've got my cycle starting. Notice it's x plus pi over 4. That tells me that the cycle is starting at negative pi over 4. So if I find negative pi over 4, that's right here. And if I look to see where my cycle is starting, notice that it's starting in the middle. The fact that it's starting in the middle tells me it's a sine function. Notice then that it goes down. Well, a positive sine function increases first. So this should be a negative sine function. And when I look at the equation, I see a -3 times the sine of x plus 4, or I'm sorry, x plus pi over 4 minus 2. So that 2 is correct. And then in the last one, our cycle should be starting, and since this is a positive 11 pi over 4, I'm actually going to start it at a negative 11 pi over 4. So again, each of the little increments is a pi over 4. So if I count 11 over, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's my 11, and notice that my cycle is starting at the top. That tells me it is a positive cosine function. And if I look at my equation, I can see that my amplitude is positive. It's a cosine function, so that too is correct. So the question is asking which is not a possible equation for the graph. That would be number 2. All right, number 6. Now instead of being given the equations, you have to write the equations. And so you're told that the cycle starts at different points, A, B, C, and D. But remember from the last one that the amplitude of all your functions and the midline of all your functions is going to be the same. So I'm going to go ahead and plot the midline first. I can see that it's right here. And that value occurs when y is equal to 2. Okay, and so that's my midline. So I know then that all of my equations are going to have this plus 2 at the end. I can also see that my amplitude, if I count how many units there away the max is from my midline, or the min from my midline, I can see that my amplitude is 3. So I'm going to have a y equals, y equals, y equals, and so forth. And I know my amplitude for all these functions is 3. In some cases, it's going to be a positive 3. In some cases, it's going to be a negative 3. I have to now examine where the function starts and then the behavior of the graph to see if it's going to be a cosine or a sine function. So let's start at point A. Here's point A. Notice that it starts in the middle of the graph, okay, at the midline. So that tells me it's a sine function. The fact that it increases tells me it's a positive sine function. So I'm going to have y equals 3 times the sine. Now I've got to think about where the cycle starts. If I go down to my x-axis, I'm given the value, and I actually can't see it on my smartboard, so let's see, I'm given the value negative 3 pi over 2. What I have to remember though is when I put it into parentheses, it's going to be a positive 3 pi over 2, because in the formula it's x minus h. And you can use an x instead of a theta or a theta, it doesn't really matter. Okay, so let's take a look at the next one. Point B occurs way down here. So the fact that it starts at the bottom of my function tells me that this is a cosine, because cosine starts at the top and ends at the top. So the fact that this starts at the bottom tells me it's a cosine function, but it's been reflected. So this is a negative cosine function. And I want to think about where the cycle starts. Notice that it starts at 0. So that's the same thing as saying theta minus 0, or simply theta. Letter C. So this letter C means that the function or the graph or the cycle starts at the top of the graph. That again tells me it's a cosine function. And because it's starting at the top, it's going to be positive. So I'm dealing with the cosine of theta. And if I go down to my x-axis, I can see, or my theta axis, I can see that that value is up at pi. And so inside my parentheses, I'm going to have theta minus pi. And in part D, if I look at point D, I can see that the graph, again, starts in the middle and then goes up. So that tells me this is a positive sine function. And so I now just need to look at my x-axis or my theta axis, and I can see that that occurs at 5 pi over 2. And so remember, it's going to be theta minus 5 pi over 2. Okay. And so the same curve can be modeled by each of these equations. All right, and number 7, it says, suppose the function f of x, which is negative 65 times the sine of x plus 14 plus 80, represents the height above ground in feet of a roller coaster. What are the maximum and minimum heights of the roller coaster? Well, let's see what we remember about the equation. Remember, the 80 is our midline, and the 65 is our amplitude. Okay, and so if you think about just doing a curve, so if my midline occurs at 80, and my amplitude is 65, that means my max is going to be 80 plus 65. So 80 plus 65 is 145. And if I want to find my min, I'm going to take 80 minus 65. And notice we don't have to worry about the negative symbol. And so that means my min is going to be 15. Now you're not asked to graph it, you're really just asked to find the max and the min. So another way to think of it is that your max is going to equal the midline plus your amplitude. And your min, which in this case we got 145, And that is in, I think it's in feet, does it say? Yeah, in feet. And to find the min, we're going to take our midline minus our amplitude. And when we did that, we got 15. And that again is going to be in feet. Okay? All right, number 8. This has to do with function composition, and it's a real-life example of what you do when we're composing functions together. So in number 8, it says you're shopping for a rug online. You find a rug you like, and the original cost is $249. That's the original cost. The website is running a weekend promotion of 30% off. You also receive a gift certificate from your mother in the amount of $50. So we get another $50 off, and it can be applied, this is important, it's going to be applied after the 30% off. You must also add 8% sales tax. Now this is actually a real application, and I wrote this problem last year, and for my birthday, my mom actually got a rug for me, and this is actually part of the deal. Like, it was promotion, my mom gave me money towards it, and obviously I had to pay tax, and then as well as the tax, I had to pay a $12 shipping and handling fee at the end. Okay, so there's a lot going on. There's a lot going on in this problem. So let's take it one step at a time. And we want to make sure that we go in the proper order that the problem tells us. So we've got basically 100% of the value. And then we're going to, let's see, we're going to take 30% off. I get to take off another $50, and then I have to apply 8% sales tax and then add $12 on top of all that. So there's a lot going on. So if we use a value of X as the original cost, the first thing we want to do is apply the 30% off. Well, if I'm paying 100% of something and I take 30% off, that means I'm actually paying 70% of the value of the rug. And so that means that this expression is going to become 0.7, because remember, you want to change all of your percents to decimals. So I'm actually paying 70% of the value of the rug. So that's going to be 0.7x. Okay, or 0.70x if you want to do it that way. The next thing I need to do is apply the $50 gift certificate that my mom gave me. So after paying 70% of the value of the rug, I'm now going to subtract $50. Okay? The next thing I'm going to do after that is apply 8% sales tax. Now, the whole total is going to be taxed, so I'm going to put that in parentheses. And now I got to think about how I'm going to apply 8% sales tax. Now, be careful. Let's think for a second. If I buy something that is $100 and I apply an 8% sales tax, I think you probably recognize that you're going to need to multiply by 8% or 0.08. But when you do that, you're just going to get 8. Now, 8 is not the amount you're going to pay. You're going to pay the original $100 plus the 8. Now, the $100 that you're paying is the original 100%. So this is 100% plus another 8%. So really, you ultimately end up paying 108% of the value of whatever it is. So just like we subtracted 30% from 100 to take the discount, I'm going to add 8% to 100 to pay the tax. So I'm going to multiply by 1.08 because that tells me I'm paying 100% of the price plus another 8% sales tax. So I'm paying 108% of that. Well, in this case, it's a discounted price, but that's why I'm doing 1.08. And then after that, I've got to pay shipping and handling, which is not taxed. So that's why it's not going to go in the parentheses, and I'm just going to add a plus 12. So let's review real fast. The first thing I'm doing to my costs, remember X is the cost of this rug, is taking off 30%. Well, I'm not going to keep it as 0.3x because remember, that's just the amount I'm getting discounted. I have to subtract that from the whole price. So another way of looking at this is to say, okay, well, I'm paying 70% of the value of the rug. So that's why I have the 0.7 there. The next thing we did was subtracted the $50. Then we had to apply sales tax. But remember, I don't want to just apply the 8%. I also have to consider the 100% of the value that I'm paying. So that's why we're multiplying by 1.08. So when you're adding sales tax, you're going to be adding that tax to 100%. If it's a discount, you're going to be subtracting that from 1. And you may remember when we were doing exponential functions, remember how we had like exponential growth? And if we were just dealing with annual growth, we had our original value and then we did 1 plus r. and then it was raised to the t. That's why we're adding, and we just have to make sure that we change the percents to decimals. With decay, or in this case, if we're taking a discount, if you remember the formula, we had a times 1 minus r to the t, because we have to take the 100% and then subtract the discount. And so that's essentially what we did. So 1 plus r is what we did here for the sales tax, and 1 minus r is what we did here for the discount. And then the shipping and handling is added to the end. So that is the formula that we're using to find the discounted, or the total price, or the final cost of this rug that we're buying online. So then what is the amount that you're going to be charged for the $249 rug? So basically we're just going to go ahead and let x equal 249, and I'm going to plug it into my formula. 1.08 times 0.7 times 249 minus 50 plus 12. And we can just do this on the calculator. 1.08, and then in parentheses, 0.7 times 249. And then I need to subtract the $50 from my mom, and then add the 12. And we end up paying $146.24. And so that's the final cost of the rug. Pretty good deal. All right, in number 9, this gets back into our statistics unit. So number 9 says a researcher wishes to determine if there's a difference in the voting patterns of teachers. She wants to determine whether teachers in rural, suburban, or urban schools tend to vote more often for Democrats, Republicans, or Independents. In addition, she believes that the level of education as measured by the type of degree earned, whether it's a bachelor's, master's, or PhD, may influence the voting patterns. She randomly selects a sample of 100 teachers from each geographical location in her state and sends them a survey. So the first question is asking which type of sampling method best describes her design. Well, notice that she is taking a sample of 100 teachers from each geographical location. So it's not really defined what the geographical location represents, but maybe it's zip code, for example, or maybe it's county. So if I am breaking the state up into groups, into geographical locations, and then taking a sample from each group, that is a stratified sample. If I'm breaking the state up into geographical groups and then I'm selecting a random sample of groups or locations, that's what we would call a cluster. If she is just simply taking a sample of 100 teachers from names on a list, that would be a simple random sample. If she was systematically going through a list of names, for instance, maybe she's choosing the 10th name on a list, or if she's got a list of certified teachers in the state, maybe she's going through systematically and picking the 50th person on the list. That would be a systematic random sample, and convenience would be whoever's easiest for her to contact. That would be a convenience sample. So in this case, because she's separated the state into geographical locations and then sampled from each geographical location, that is a stratified random sample. Part B, which type of study best describes the situation? Is it a simulation? Is it an observational study, an experiment, or a hypothesis test? We didn't really get into hypothesis tests in this course this year, so obviously if you see that on the final, you don't have to worry about it. But a simulation is basically when we try to model a random situation. So for example, if I'm, we use dice sometimes, or maybe flipping a coin to represent having children, because the chances of having a boy and a girl are both 50%, so we can flip a coin to simulate having a boy or a girl. So this isn't a simulation. The difference between an observational study and an experiment, remember, is in an experiment, we are applying some sort of a treatment. We're doing something to our subjects to measure their reaction to it. And in this case, she's just interviewing people or sending them a survey. She's not really trying to change their voting patterns or anything. She's just trying to explore what the voting patterns are. And that is the definition of an observational study, where we're just trying to understand the situation. We're not trying to change it in any way. We're just trying to gather information that already exists. And so a sample and sending a survey is going to be a type of observational study. All right, and number 10, it says the heights in centimeters of male and female students in a class are summarized by the following box plots. Is it reasonable to conclude that males tend to be taller than females? Use the differences between the two distributions to justify your answer. So this is obviously a constructed response question. When you're asked to compare the differences, I want you to think back about first semester when we were doing argumentative writing, where you were comparing two things and you were having to cite evidence, and you had to find several forms of evidence in order to justify your claim. So when you're asked to justify your answer, I want you to think about citing 3 pieces of evidence. And the evidence in this case is going to be the number summary associated with the box plot. So we're trying to say, is it reasonable to conclude that males are taller than females? Well, look at the box plots. I mean, I can see that the box plots for males is certainly shifted higher on the axis than the females. But I want to be very specific. So we might want to have a statement saying, yes, it's reasonable to conclude that males are taller than females. Here's why. Okay, and we want 3 statements. Okay, so the first thing I notice is that the minimum for males is higher. And remember with the box plot produces the 5-number summary, which basically breaks a distribution into quarters. So for example, this part of my box plot represents 25% of males. So that would be true on this bottom whisker. That's 25% of females. So what I can see is the minimum height for males. That means 100% of males are taller than that value. The minimum height for males is still taller than the lowest or the shortest 25% of females. That's the first thing I notice. So, and I'll go ahead and say the shortest male, and I'll even put the value in there because when we state evidence, we also want to use the numeric summary. So the shortest male was 160 centimeters, I believe. The shortest male is taller than 25% of the females. Okay, so that's one piece of evidence. Another piece of evidence that I notice is that, the median for males is above the 3rd quartile. So the median guy, so the middle guy, is taller than more than 3/4 of the women. And so the median height, it looks like if this is 175, maybe the height is maybe 178 centimeters. So a typical male, because that's what the median is, a typical male is, let's say, 178 centimeters, which is taller than over 75% of the females. Okay. And next thing I notice, and you can use different measures. I'm just sort of kind of going in order. The next thing I notice is the 3rd quartile for men is the same as the maximum height for women. So basically 25% of the men, this 25%, are taller than 100% of the women. So since the 3rd quartile for men, and let's see, that value was at, it looks like maybe 182. Is larger than all the females. Or is the same as the maximum height of the females. It's probably more accurate to say that. So, 25% of the men are taller than all of the women. Okay, and then with any written statement, you want to conclude it. So here are the reasons why. These are just some reasons why. I'm concluding that men are taller than women. Okay, so remember your writing skills from first semester when you're answering this question. Okay, and there'll be a rubric, and so just remember, if it's, you know, a 4-point rubric, you want to make sure that you're giving us enough points, enough evidence to achieve those points. All right, number 11. This goes with something we've done more recently with properties of exponents. So these problems, there are several different properties at play here, and there are different strategies that you can use, different orders that you can go in when simplifying these expressions. So in the first one, we've got 6m squared n divided by 2m to the third, I think that is, it's hard for me to see on this thing, times n to the negative 4. So the first thing I'm going to do in this expression is take care of, I'm going to deal with my order of operations, and so I'm going to deal with this expression right here, that 2m, the quantity cubed. And so when I've got a product and I'm raising it to a power, that tells me I need to distribute the power to each term. So on the top of my fraction, I've got 6m squared n, and on the bottom now, if I distribute that power, I'm going to have 2 to the third, and be really careful that you don't mix up your rules for exponents with your rules for numbers. So 2 to the third is 2 times 2 times 2, which is 8. So I'm sure that there are some of you that probably did 2 times 3 because that's what we do with the exponents. We multiply them. But remember that your rules for numbers are the same as they've always been. 2 to the third is 8. And then I've got m cubed. When I look at the n to the negative 4, remember, with negative exponents, there are a couple things you can do. You can leave it there and then use your properties of exponents to simplify, or I can think about my negative exponent rule, which basically says if I have a negative exponent, that's the same as taking the reciprocal of the base. And so if I'm dealing with a fraction, if my negative exponent is in the denominator, if I move the term to the top, I can make the exponent positive. So now this becomes n to the fourth, and it's on top. The next thing we want to do is just go ahead and start combining our like terms. So I'm going to deal with my numbers, I'm going to deal with my m's, and then I'll deal with my n's. So 6 over 8 is going to reduce to 3 over 4 because both of those numbers are divisible by 2. So we're going to have 3 over 4. Let's deal with the m's. You can do this a couple different ways. If you use your properties of exponents, then the rule when you're dividing is to subtract them. So you'd end up with m to the negative 1. And m to the negative 1 would end up on top of your fraction. But we don't want to leave any of our exponents negative. So ultimately what I would do is I would move the m to the negative 1 to the denominator of my fraction, and it would just become m to the 1 or simply m. Another way you could do this, and I think a lot of people prefer this, as long as your exponents are positive, you can cancel. So m squared over m to the third means I basically have 2 factors of m on top and 3 on the bottom, which means that I can cancel 2 pairs. And that leaves me with an m on the bottom. So sometimes canceling makes a little bit more sense. Finally, let's go ahead and deal with n. I've got n times n to the fourth. Remember, this single factor of n, even though you don't see the exponent is 1. And when we're multiplying powers that have the same base, we add the exponents. And so that leaves me with n to the fifth power on top. All right, in letter B, we're basically taking a product, 4x, y to the 2/3, and we're raising it to a power. And our rule says as long as it's just multiplication or division, I can distribute that power to each term. So I'm going to have 4 to the 1/2 times x to the 1/2 times, and I'm going to put this in parentheses because I have y to the 2/3 that I now am raising to the 1/2 power. So let's deal with each one of these individually. 4 to the 1/2. Remember, when you're dealing with fractional exponents, the number in the denominator is your root. The number on top is the power. And so this is 4 to the 1/2 is essentially asking me to take the square root of 4, which we know is 2. I can't really do anything with the x, so I'm going to leave it just as x to the 1/2. And when I get to the y, now I'm dealing with my power to a power. Y is already being raised to a power, but then it's also being raised to another. So we multiply our exponents, and 2/3 times 1/2. Remember, with fractions, we multiply across the top, we multiply across the bottom, and that's going to give me 2 over 6, or 1/3. Another way to do this is simply to cancel those 2's, and you're going to end up with y to the 1/3. A lot of you make mistakes when you're dealing with fraction operations, so if you're uncomfortable doing it by yourself or on, by hand, go ahead and do it on a calculator. 2/3, just make sure you put your fractions in parentheses, and then we want to multiply by 1/2. When you press enter, you're going to probably get a decimal, so make sure you go to math and change it back to a fraction, and there's your 1/3. In letter C pretty much breaks down like we did in letter A. We've got 6x to the 2/3 y divided by 12x y to the -2. And so it's easiest if you just start looking at like terms. And again, I've got this negative exponent on the bottom, so I a lot of times just move those negative exponents around to make them positive, and it makes it a little bit easier. So I'm going to rewrite this so it's a little bit easier to see. We've got 6x to the 2/3 y over 12x, and then I decided because that y to the -2 on the bottom, if I move it to the top, that means it's going to be y to the +2 on top. And so now, again, like what we did in letter A, I'm going to combine my like terms. 6 over 12 is 1 over 2. Make sure you keep things where they belong in the fraction. So a lot of you will divide and know that the quotient is 2, but remember, because it's a fraction, 6 over 12 is going to reduce to 1/2. Now with my x's, it was a little bit easier with my m's because the numbers were whole numbers and I could easily cancel them. When I'm dealing with the fractional exponents, I really do have to consider my properties because I can't just cancel. I've got x to the 2/3 over x, and remember that's the same as saying x to the first power. And when we're dividing, we subtract our exponents. So it's going to be 2/3 minus 1. Again, if you're not comfortable with these operations, then do it on your calculator. 2/3 minus 1. We're going to get a decimal, so we can change it back to a fraction. And notice that we have -1/3. So if I put this on my paper, I want to make sure that I put that on the top. When I use that property and I subtract the exponents, my result is going to end up on top. Now it's a negative exponent, so I'm ultimately going to need to move it back down, but I'll do that in just a second. Let's deal with our y's. This is y to the first times y squared, and so when I'm multiplying, I can add my exponents, and that'll give me y to the third. But again, I do need to make sure that I move that term down to the bottom of my fraction. And so I'm ultimately just going to have y to the third on top. I don't have to put the 1. And that's going to be over 2x to the 1/3. Okay. In number 12, you're asked to divide. You've got x to the third minus 6x plus 8 divided by x plus 3. You can use long division here, but because what we're dividing by is very simple, it's just an x plus 3, I can also use synthetic division. Just remember with synthetic division, so if I have x plus 3, my x-intercept is -3. So if I'm going to use synthetic division, I need to make sure that I'm using my x-intercept of -3. The other thing that we have to be careful of with synthetic division especially is that I use zeros to hold any missing terms. So here I've got x to the third. Notice that there's no x squared term. I need to remember to put a 0 there as the coefficient. And then I've got minus 6x plus 8. So with synthetic division, we're just going to list the coefficients. So that's 1, 0, -6, +8. We give ourselves a little bit of space, and then we begin. We always bring our first term straight down. And then remember, we multiply. So -3 times 1, I put my answer up in the next spot. And then we always add. So remember, with long division, we subtract at this point. Because I changed what I'm dividing by, because I changed the sign there, so that I've already dealt with a negative. So now I can just add, and it makes it a lot easier. So I'm looking at 0 plus a -3, which is just -3. Then we multiply. -3 times -3 now is a +9. When I add, I get 3. -3 times a +3 now is a -9. And when I add, I get -1. Now in this case, that -1 is my remainder. And so when I write my answer, remember we started with x to the third power, but I divided an x out. So if I'm pulling an x out, that doesn't leave me with 3 factors of x anymore, it leaves me with 2. So the 1 that I have here is going to be the coefficient of x squared. And then I'm going to have minus 3x plus 3. And then my remainder is going to be minus 1 over whatever it was that I was dividing by, x plus 3. And again, you could do long division here if you're more comfortable with it, but you still want to include the 0 next to the x squared. The next problem, it says the following formula can be used to determine the price of a single toy where L represents the cost of labor and M represents the cost of materials to produce a shipment of toys. If the cost of labor is $110, so that gives me a value for L. So if L is $110 and the cost of materials is 75, so that means M is equal to 75, determine the price of the toy. I'm just going to plug these values in. The price then is going to equal 110 times 75 over 2 times 110 minus 75. And I can do this on the calculator. Make sure you put both the numerator and denominator in parentheses. So I'm going to go like this just to emphasize the need to put those parentheses in there. So I'm going to have parentheses 110 times 75. That's going to go on top. And then I'm going to divide by, and I need to put parentheses around the whole thing, 2 times 110 minus 75. And my parentheses. And that tells me that the price is $56, and that's going to round to 90 cents. Okay? In letter B, it says at a particular plant, the cost of labor is $25 less than the cost of materials. So the cost of labor is $25 less than the cost of materials. So let's translate that into an equation. So the cost of labor, L, that's an equal sign, $25 less than the cost of materials. So I know less than means subtract, and if I'm taking 25 away from the cost of materials, that's going to look like M minus 25. So what we're asked to do is to rewrite the formula, but I'm going to replace the L with my M minus 25. So I'm probably going to need a lot more space here. So I'm just going to ignore the letter C for a second while I do this. So that means the price is equal to L, but I'm not going to write L. I'm going to write M minus 25 times M. That's on top. And then on the bottom, I'm going to have 2 times L. But again, I'm not going to write L. I'm going to write M minus 25 and then minus M. Okay, I'm not going to use the values that I had in letter A. I'm just trying to rewrite the formula. So when I do this, it's because it says to write your answer in simplest form. I'm going to use my order of operations. So on top, I'm going to need to use the distributive property, which means I'm going to have to multiply M times M and then M times that negative 25. So that's going to become M squared minus 25M. That's going to be on top. On the bottom, I'm going to have to distribute the 2. That's going to be 2M. This is going to be minus 50 when I distribute it to the negative 25. And then I still have this minus M. And so when I simplify, I'm going to have M squared minus 25M over, now that I can combine my M's, 2M minus M is just M minus 50. Okay, and so that would be my answer to letter B. In letter C, it says to use division to rewrite the formula as a polynomial in standard form. Since I used synthetic division in the last problem, I'm going to use long division in this one. Even though in this case you could actually use synthetic division because what you're dividing by is simple. It's just M minus 50, so we'd use an x-intercept of positive 50. So if I'm going to use long division, I'm basically taking M minus 50 and I'm dividing it into M squared minus 25M. Now I still will put a plus 0 because I still like to hold all of my place values. And so the first thing I'm going to do now is think about, I'm not really thinking how many times does M minus 50 go into M squared minus 25. I'm thinking how many times does M go into M squared? Or simply, what do I need to multiply by M to get M squared? And I know I need an M. So that's going to go over the second term since there are 2 terms that I'm dividing by. So now I'm going to multiply. M times M is M squared. And M times a negative 50 is going to give me a negative 50M. Now the next step is to subtract. And this is where people always make mistakes. It's easy to see that you're going to subtract the M squared. But you also have to distribute the subtraction symbol to the negative 50M. And when you subtract a negative, it becomes a positive. So now those first terms should always cancel. And when I combine the next terms, I should have a 25M. Then my next step is to figure out how many times does M go into 25M? Or simply, what do I need to multiply by M to get 25M? And I need 25. And so now I'm going to multiply. 25 times M gives me, and I can bring down this 0, even though it's really not going to make a difference. If I multiply, I get 25m, and then 25 times a negative 50 is a negative 1250. Ooh, we're going to have a remainder. All right. And then the next step is to subtract. And again, I'm subtracting here. And when I subtract a negative 1250, it becomes a positive 1250. And that is going to be my remainder. So when I write my product, or I'm sorry, when I write my quotient, I'm going to have m plus 25 plus 1250 over whatever it was that I was dividing by, m minus 50. Okay, and that is your final answer for letter C. All right, so this first part of the video is just on the calculator section of the test. I will do a part 2 for the non-calculator section, so look for that as well. Good luck.